Hello there viewers, I'm back with another tutorial. This time we're going to be doing something similar to the last tutorial. Instead of converting binary to decimal and decimal to binary, this time we're going to be converting binary to text and text to binary. Now, we can't just convert text to binary. We have to convert that text to a decimal and then that decimal to binary. And then the exact opposite if we want to convert binary to text. We would convert the binary to decimals and then the decimals to text. So basically what we're doing here is we're converting the text to ASCII, ASCII to binary, and then binary to ASCII, and ASCII to text. So if you already watched my previous tutorial on these two functions, then you can skip ahead, and if you are new to the tutorial, then you can watch me explain this. So basically, we have two functions, convert to binary and convert to decimal. The first convert to binary function, what it does, is it takes a decimal as an integer and returns a string. Now it declares four variables inside of it: n, c, k, and fs. N and c do all the calculations of what the binary is, and k holds the binary, but then there's a problem. K holds the binary, however, that binary is flipped around. It's not the correct binary. It's in reversed order. So we need to reverse k inside of fs to get our final string. And so basically what we're doing next is n is equal to decimal, meaning this n variable is equal to the decimal that we asked them for. And then we are doing a while loop while n is greater than 0. And so what we're doing inside of here is we are checking, we're not really checking, we are doing c is equal to n modulus 2. Now this gets if the current digit should either be 0 or 1. So let me explain that really quick. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically, here we have numbers 1 to 9. Now, anything modulus 2 is either going to be 1 or 0. That's because numbers, basically, the answer of a modulus, or the remainder of a division statement, can only be that this number, this, on the end, minus 1. That's the only number it can go up to. So for 2, that would be 1, meaning 0 and 1. So for 1, the modulus, 1 modulus 2 would be 1, and then 2 would be 0. 1, 0, 1, 0, 1, 0, 1, and it'll keep going on like that. So basically, if the number's even, then it's going to be a 0. If it's odd, then it's going to be a 1. So, now that we've gotten that out of the way, C is either going to be a 0 or a 1. Then basically what we're doing is we are dividing n by 2 and setting that value inside of the n variable. So we basically divide n by 2, meaning we half it. We basically chop it in half. And then we are adding to k as a string. We are adding whatever's inside of c. But then the problem is that k is currently reversed, so we need to reverse it again so that it becomes the correct order. So what we're doing is we are looping for I inside of reverse k, meaning it reverses k and loops through. So fs plus equals I. So we're basically putting all that binary into fs, and then we're returning fs. And then in the convert to decimal function, we're taking the binary value as a string and returning a string. So we are creating a result variable inside of the function, and this is an int and it's equal to 0. And then we are doing a for loop here, as you can see, and so it's for num in binary val. So we're taking whatever we have from the user and we are looping through it with the variable num. short for number. And then we are doing a switch case on num, and then we're checking if it's 0, then the result is equal to the result times 2. However, if it's 1, then the result is equal to the result times 2 plus 1. And then if it's anything else than that, then just return an error because that's not a binary value then. So now let me show you the actual code behind the binary to text and text to binary. So as you can see, this huge chunk of code, this is all of the basically text to binary. So if I enter any text in here, you will see the binary for that text come in here. So let's just say I type in, oh, I don't know, and Bakshi created this playground. Okay, so as you can see in just a second, you will see this execute and the binary gets copied on here. And then if I go onto a website, binary to text, I will put a link to this website in the description if you'd like to test any of your scripts. And so here we are. As you can see, our program properly encoded this text into binary, and I copied this binary, put it in here, and as you can see, it gives us the text. Tanmay actually created this playground in the exact same case also that this is. So now, as you can see, what it's doing is it's taking this string, it's converting it to ASCII, and this is the array of all the characters and ASCII values. So as you can see, if I say 0, 1, 2, 3, 4, 5, so basically a space here is ASCII 32. A capital T is 84. A small a is 97. A small n is 110. A small m is 109. 97 is a small a, as I mentioned, and 121 is a small y. So as you can see, all the characters have their own ASCII value, including the dot at the end, which is 46. And so all these decimals get converted to 8 digits of binary, and then those 8 digits of binary are stitched together into one entire loop of binary and then decoded later. So let me explain exactly how this works now. What we're doing is we are declaring 4 variables: start string, ASCII final, binary array, and binary. So inside of start string, we are creating an S string, and it has nothing in it, and this is where you put the string that you'd like to encode. And then we have an ASCII final array. This is all the ASCIIs in their final state. And then we have the binary array, which is all binaries, basically all 8 digits of binary together in an array, and then the binary string, which is what eventually will contain the binary. Now, the reason we had to have the binary string is because the binary array has all the 8 digits of binary in separate basically columns. However, we need to take all of those binary elements and put them all together into that one string. So that's why we have that there. And then we're using an Objective-C style for loop. We're creating a variable called I, and it's equal to 0, and then we are doing for I is equal to 0, I is less than start string dot length, and I plus plus, so that's the increment every time. What it's going to do inside of that for loop is the ASCII code, which is an integer, is equal to the start string dot character index I, meaning it's looping through that string, and each character gets converted to an ASCII code, and that ASCII code is appended to the array. Once that's done, we're just printing all the ASCIIs, and then we are looping through the ASCII array. What we're doing then is we are appending to the binary array, and what we're appending is that ASCII converted to binary. Now the only problem is our convert to binary function does not handle converting it from, let's say, a 6 or 7 digit binary into an 8 digit binary, since that's how we organize it. Now the way we fix that is through another for loop. And this is actually a little complicated, and I do not need this variable here. So basically we are looping through the binary array, and we are creating a variable called string to submit. Now this string to submit is completely empty right now, and then we're checking. If the binary is actually currently less than 8, then it'll do something, or else it's just going to return it. And then so basically if it is less than 8, then we're creating a variable called toAdd, and it's equal to 8 minus how many elements there are inside of the binary little code. And so that tells the for loop how many zeros you need to add to the beginning of that binary. So what we're doing next is we are doing another for loop inside of that for loop, and what that's doing is it's looping in from 0 to toAdd. Now the reason we couldn't do 1 is because if this was 1, then that would be a problem and it wouldn't execute. However, now what we can do is just make sure that if I is not equal to 0, meaning it only happens once, not twice, if it's 1 times it needs to go, then string to submit is, we are adding 0 to string to submit. Now the problem is, let's say we need to add 2 zeros. The string to submit, since it's completely empty, will only be 2 zeros. So we're adding into the binary string, the string to submit, which is all the zeros, and then I, which is that binary that doesn't have 8 digits, but because of us putting those zeros in front of it, it will now have 8 digits. And then else, as I said, it's just returning I. And then we're printing the binary. So once again, if I type in some text, hello, Frank, it'll give me the binary value for it. As you can see, all the ASCII values, and then I can take this binary value, copy it in here, and it's correctly encoded. So next is the basically binary to text, and what this does is it takes any binary you give it and converts it to text. So as you can see, this is a much shorter program, and what it's doing is it's declaring 3 variables first of all. And those 3 variables are binary to convert, which is a string, which is the binary you have to convert. And then the ASCII's after convert, which is an array of integers, which is, again, the ASCII's you get after converting the binary to ASCII's. And then the final text is just those ASCII digits put into text. And so we are then declaring 2 more variables, on and binary, equal to 0 and nothing respectively. And then we are looping through the binary to convert array. I mean string, but we're looping through it character by character. We are incrementing the on variable, and we are setting we are basically adding i's value to the bin string, and then we're checking if it's been 8 digits, if it's been 8 increments, meaning there's 8 digits inside of the bin variable, then we are appending something to the ASCII's after convert array, and what we are appending is the convert to decimal of that binary, meaning we are extracting the ASCII code back out of that binary and converting it to an integer. Then we are setting the binary back to nothing and on back to 0. And that ends the for loop. And then one last for loop, for I in ASCII's after convert. What this is doing is it's taking all those ASCII's, forming it together into one final string. And so what I'm doing here is the final text plus equals that string's Unicode scalar I. So it's finding the character value of that ASCII, and then it's basically appending it to the final text. So if I go here, this program that I, Tanmay, Bakshi, created can handle long messages such as this one. It can also handle long paragraphs and does binary to text and text to binary conversion. It does all symbols correctly and works perfectly. And then if I click to binary, it gives us a gigantic chunk of binary, which I can then copy, put into the program, and if we wait a while, and I think I should remove this so it doesn't take up some memory, if I just paste it in here, and that's a ton of binary. As you can see, this program will be able to convert it to text. These for loops are just going off a ton of times, and it's executing. Yeah, so till then, while that's happening, I guess I'll tell you that, oh yes, it's done. So, as you can see, this program that I, Bakshi, created can handle long messages such as this one. It can also handle long paragraphs and does binary to text and text to binary conversions. It does all symbols correctly and works perfectly. Yeah, so as you can see, it can also convert a huge chunk of binary like this one. And yeah, that was the tutorial. Comment if you're, subscribe if you're new to the channel. Comment for any suggestions, improvements, or if you have a question. Like if you liked the video, and goodbye. I'll see you in another video. Thanks. Take care. Bye.